Good evening. Actually, these two sums, third and fifth, were given for homework, but let us discuss those sums. Third one, limit extends to pi by 6, 2 minus root 3 cos x minus sin x upon square of 6x minus pi. Obviously, you have to put x equal to pi by 6 plus h as x tends to pi by 6. H will tend to 0. So 6x minus pi on simplification becomes simply 6h. And what about this? Root 3 cos x plus sin x. Substitute x equal to pi by 6 plus h and then simplify. See what you get. Cos of alpha plus beta, sin of alpha plus beta. You will notice on simplification, you simply get 2 cos h. And therefore, the sum becomes limit h tends to 0, 2 minus 2 cos h upon square of 6h. See how 2 cos h is obtained. You can see this after the lecture. In fact, I have told you that sin of alpha plus beta, cos of alpha plus beta formulae are used. Now, 2 into 1 minus cos h upon 36h square. If you have 1 minus cos, multiply numerator and denominator by 1 plus cos. So that gives me 1 minus cos square, that is sin square in the numerator. Now sin square h upon h square is square of sin h upon h. One more option is replace 1 minus cos h by what? 2 sin square h by 2. But it is better that you multiply by 1 plus cos h. So this is 1 upon 18 into, now what is limit of square? Square of limit. Please do not write 1 square here because standard limit is this one. Into limit of this part. Take the limit. Here to take the limit means to replace, here to take the limit means to use standard trigonometric limit, and here replace every h by its limiting value, which in this case is 0. So standard limit 1, 1 square, cos 0 is 1. So 1 upon 36 is the answer. Next one, limit extends to pi by 2, cos 3x plus 3 cos x upon 2x minus pi cube. Same, put x equal to pi by 2 plus h. As x tends to pi by 2, h will tend to 0. Simplify this. See, before that, what is cos 3x? It is 4 cos cube x minus 3 cos x, so that this gets cancelled. And therefore, now cos of pi by 2 plus h becomes minus sin h. Its cube is again negative. Rest part is simple. So minus 4 upon 8. Limit of cube is cube of limit. This is standard limit. Its value is 1. So final answer is minus 1 upon 2. Yesterday we discussed these three standard results. Limit extends to 0. A raised to x minus 1 upon x is log a. Index tends to 0 and is fully repeated in the denominator. General case can be considered as limit a raised to mx minus 1 upon mx, x tends to 0 is log a. Now e is again an irrational number greater than 0 not equal to 1. So you can replace a by e to get log e, but log e is 1. Third result is important. Limit extends to 0. 1 plus x raised to 1 upon x is e. How to remember this? Something is added to 1. Same thing tends to 0. And index is a reciprocal of the term added to 1. Value of the limit is nothing but e. The generalized version is limit extends to 0. 1 plus mx raised to 1 upon mx equal to e. Right now. Oh, I'm sorry. You already written. Now we will directly start solving sums from exercise 7.6. The first one, limit extends to 0, 9 raised to x minus 5 raised to x upon 4 raised to x minus 1. See, in standard form, we need a raised to x minus 1. So rearrange the terms in the numerator. 9 raised to x minus 1 minus in bracket 5 raised to x minus 1. So we have written the same numerator in required form. Now divide numerator and denominator by x. x only tends to 0, not equal to 0, right? Now next part is simple. Limit of quotient is limit of numerator upon limit of denominator. And what is limit of difference? Difference of limits. So this is nothing but limit x tends to 0, 9 raised to x minus 1 upon x minus limit x tends to 0, 5 raised to x minus 1 upon x divided by limit x tends to 0, 4 raised to x minus 1 upon x. So this is log 9 minus log 5 divided by log 4. Now use laws of logarithm. So log of 9 upon 5 upon log 4. So this is the final answer. Of course, you have to mention the standard limit also. Which standard limit is used? Limit x tends to 0, a raised to x minus 1 upon x is nothing but log a. Right now. Second sum. Let L be the limit x tends to 0, 5 raised to x plus 3 raised to x minus 2 raised to x minus 1 upon x. Can we take the limit? No. 5 raised to 0 is 1, 1, 1 plus 1, 2, minus, this is again 1 on taking limit, again minus 1, 0 by 0 form. Now we need function in which form? A raised to x minus 1. So rearrange the terms 5 raised to x minus 1 plus 3 raised to x minus 1 minus in bracket 2 raised to x minus 1. Before you proceed, please check whether you have written the same numerator. You can write numerator in different form, but you cannot write different numerator, right? Split numerator, limit of sum is sum of limits. Now each function is in standard form. So log 5 plus log 3 minus log 2. So this is nothing but log of 15 upon 2. I hope you understood this. Okay. Now which standard limit is used? We have to mention this. Limit x tends to 0, a raised to x minus 1 upon x is nothing but log a. Right now. Third one, let L be the limit x tends to 0, a raised to x plus b raised to x plus c raised to x minus 3 upon sin x. Now rearrange the terms in the numerator, a raised to x minus 1 plus b raised to x minus 1 plus c raised to x minus 1 upon sin x. Now divide numerator and denominator by x. See, division is valid because x only tends to 0, not equal to 0, right? So L equal to limit x tends to 0, a raised to x minus 1 upon x plus b raised to x minus 1 upon x plus c raised to x minus 1 upon x upon sin x upon x. Okay. Next step, limit of quotient is quotient of limit as limit of denominator is not equal to 0 and limit of sum is sum of limits. Yes. So log a plus log b plus log c upon 1. What is log m plus log n plus log p? Log mnp. So final answer is log ABC. Right. Now fourth one, let me explain. Limit x tends to 0, 6 raised to x plus 5 raised to x plus 4 raised to x minus 3 raised to x plus 1 upon sin x. Now laws of indices. In fact, they have written this directly. See, subtract 1 is subtracted thrice. 6 raised to x minus 1, 5 raised to x minus 1, 4 raised to x minus 1. This term as it is. Now 3 is subtracted. So again 3 is added. Now, uh, can you follow this? See, what is 3 raised to x plus 1? As per laws of indices, it is 3 raised to x into 3. So if 3 is taken common, then what remains in bracket is 3 raised to x minus 1. I repeat this. See, minus 1, minus 1, minus 1. 3 is subtracted. So 3 is added. Now, what is 3 raised to x plus 1? 3 raised to x into 3. Take 3 common to get in bracket. In fact, minus 3 common to get in bracket 3 raised to x minus 1. Now raised part is simple. Divide numerator and denominator by x. Now what is the value of this limit? Log 6 plus log 5 plus log 4 minus 3 log 3 upon 1. Use laws of logarithm to get final answer as log of 40 by 9. Read this part. So fifth one, let L be the limit. Limit x tends to 0, 8 raised to sin x minus 2 raised to tan x upon e raised to 2x minus 1. Now subtract 1, add 1, effectively minus minus plus. So we have written the same numerator in different form. Divide numerator and denominator by x. Now next step is interesting. Let me explain. See how I write this. Limit x tends to 0. Actually, I'm saying divide by x, but we have discussed that index must be fully repeated. So first we write sin x, right? Into sin x upon x. I hope you are getting this. See what I have written. Actually, we have to divide by x. So effectively, I have divided by x only. The only thing is I have written sin x both in numerator and denominator. Why? Because index must be fully repeated, right? So sin x upon x, rather 8 raised to sin x minus 1 upon sin x into sin x upon x. Okay. Now same adjustment for the second term also. Then minus 2 raised to tan x, okay, minus 1 upon tan x into tan x upon x. So I have written the same. That is very important. Okay. And divided by e raised to 2x minus 1 upon x. Should I explain this again? Okay, I will do it. Divide by x. So 8 raised to sin x minus 1 upon x. But note that index must be fully repeated in the denominator. So sin x and again same in the numerator. Now we cannot take limit directly, but just imagine if we take limit, value of this limit is log 8 into 1 minus log 2 into 1. What about this? Of course, index must be fully repeated and so on. So that I will do in the next step. So in the next step, I will write limit x tends to 0, 8 raised to sin x minus 1 upon sin x, okay, into limit x tends to 0, sin x upon x minus limit x tends to 0, 2 raised to tan x minus 1 upon tan x into, this is numerator only, limit x tends to 0, tan x upon x. Okay, this is numerator, right? And what about denominator? This complete is numerator. Here I will write equal to. See, this is the limitation of slate. Limit x tends to 0, e raised to 2x minus 1 upon, let me explain, index must be fully repeated. So I write 2x, but I cannot just multiply denominator by 2. So multiply numerator also by 2. 2 being constant, I write it before the limit. Now this is log 8 into 1 minus log 2 into 1 upon 2 into 1. So what is the final answer? This is log 8 into 1 minus log 2 into 1 upon 2 into 1. Now what is log m minus log n? Log of m upon n. So log of eight by 2 upon 2. So this is log 4 upon 2. But can I write log 4 as log of 2 square? Yes, I can. So this is log of 2 square upon 2. 2 log 2 upon 2. 2 gets cancelled. So what remains is log 2, right? Now second part, first sum. Let L be the limit. Limit x tends to 0. 3 raised to x plus 3 raised to minus x minus 2 upon x tan x. What is 3 raised to minus x? 1 upon 3 raised to x. LCM is 3 raised to x. See, I have written that in the denominator. 3 raised to x bracket square plus 1 minus 2 times 3 raised to x upon x tan x 3 raised to x. Now, numerator is perfect square of what? It is perfect square of 3 raised to x minus 1. Okay. What about denominator? As it is x tan x into 3 raised to x. Now we divide numerator and denominator by x square. Divide numerator and denominator by x square. X only tends to 0. X is not equal to 0. Okay. So this is now limit x tends to 0. 3 raised to x minus 1 upon x bracket square. I have written this directly. And what about denominator? 1x is already there. So instead of tan x upon x square, it will be simply tan x upon x into 3 raised to x as it is. Should I explain this again? Okay. This is square of 3 raised to x minus 1. We divide numerator and denominator by x square. 3 raised to x minus 1 square upon x square is what? Square of 3 raised to x minus 1 upon x. Denominator x tan x upon x square is simply tan x upon x into 3 raised to x as it is. Now limit of square is square of limit and so on. So this is limit x tends to 0. 3 raised to x minus 1 upon x bracket square upon limit x tends to 0 tan x upon x into limit x tends to 0 3 raised to x. Okay. Now this is log 3. So I will say log 3 bracket square upon, this is 1 into 3 raised to 0, which is again 1. So what is the final answer? Log 3 bracket square. Remember, log 3 bracket square is not 3 log 3. If asked as MCQ, one of the options will be definitely 2 log 3. 2 log 3 is log of 3 square, that is log 9. This is log 3 square, means log 3 into log 3. Second, let L be the limit. Limit x tends to 0. 3 plus x upon 3 minus x raised to 1 upon x. See, in standard limit, it is 1 plus something. So within bracket, remember, within bracket, take 3 common from numerator and denominator. Cancel that. Actually, I have omitted one step. In fact, 2 steps. Basically, laws of indices. A upon B raised to M is A raised to M upon B raised to M. What is limit of quotient? Limit of numerator upon limit of denominator. Once again, take 3 common from numerator, denominator, cancel it. What is A upon B raised to M? A raised to M upon B raised to M. What is limit of quotient? Limit of numerator upon limit of denominator. Okay. So in the next step, see what I'm writing. Limit x tends to 0. 1 plus x upon 3. See, something is added to 1. Do you remember that logic? Same thing, that is x upon 3 tends to 0. Index must be fully repeated. I'm sorry, index must be reciprocal of what is added to 1. X upon 3 is added to 1. So required index is what? 3 upon x. Is this original? No. Original index is 1 upon x. So to get the original index, I will write 1 upon 3. This is numerator. What about denominator? Limit x tends to 0. 1 minus x upon 3. Its reciprocal minus 3 upon x is the required index but not original. To get original, raised to minus 1 upon 3. I'll explain this once again. Why to use rectangular bracket also? Because limit of power is power of limit. That is why. Something is added to 1, x upon 3. Same thing tends to 0. Index must be reciprocal of this, which is 3 upon x. But original index is 1 upon x. To get that back, 1 upon 3. Here again, I haven't written one step. You could have written 3 upon x into 1 upon 3. And in the next step, limit of power is power of limit. Same in the denominator. Limit x tends to 0, 1 minus x upon 3 raised to reciprocal of this minus 3 upon x. This is required, not original. To get original, minus 1 upon 3. Now value of each limit is 1. I'm sorry, is e. So this is e raised to 1 upon 3 upon e raised to minus 1 upon 3. So what is the final answer? E raised to 2 upon 3. Now we have to mention the reason also. Limit, which standard limit is used? In fact, we have to use another variable now. Limit y tends to 0, 1 plus y raised to 1 upon y equal to e. Of course, as x tends to 0, both x upon 3 and minus x upon 3, they tend to 0. Okay, right up. Actually, this is similar. Limit x tends to 0, 3 plus 5x upon 3 minus 2x raised to 2 upon x. Now, within bracket, take 3 common and cancel. So that gives me 1 plus 5x upon 3 upon 1 minus 2x upon 3. What is a upon b raised to m? It is a raised to m upon b raised to m. Okay. What is limit of quotient? Limit of numerator upon limit of denominator. Now next step is important. Consider numerator. Something is added to 1. Same thing tends to 0. Index is reciprocal of the term added to 1. What is reciprocal of 5x by 3? 3 by 5x. This is required and not original. Original index is 2 upon x. To get that back, we have to multiply by 10 by 3. See, 3 upon 5x into 10 by 3 is the same, 2 upon x. If you cannot write 10 by 3 directly, what you can do is, here 3 by 5, so multiply by 5 by 3. But original is 2, so 5 by 3 into 2, 10 by 3. This also works. Denominator. What is added to 1? Minus 2x by 3. Its reciprocal. Its reciprocal is the required, not original. Now how to get original index back? In 2 steps. Here it is minus 3 by 2. So multiply by minus 2 by 3. But originally 2. So minus 2 by 3 into 2 minus 4 by 3. You can verify. A raised to m raised to n is a raised to mn. See, minus 3 upon 2x into minus 4 by 3. Is it 2 upon x? Yes, it is. Now why to write like this? Because value of this limit is e. Same here. So e raised to 10 upon 3 upon e raised to minus 4 by 3. So effectively e raised to 14 upon 3 is the answer. You have to mention the reason as x tends to 0, 5x upon 3 and minus 2x upon 3 both tend to 0. Limit alpha tends to 0. 1 plus alpha raised to 1 upon alpha is nothing but e. Fourth one, let L be the limit x tends to 0, log of 3 minus x minus log of 3 plus x upon x. So basically this is 1 upon x, right? What is log m minus log n? Log of m upon n. N log m is log of m raised to n. In this step only, I have taken 3 common, of course within bracket, from numerator and denominator. Cancel that. Okay. What remains is this. Now next step is very important. Limit of log is log of limit. So this is nothing but logarithm of limit x tends to 0, 1 minus x upon 3 raised to 1 upon x upon 1 plus x upon 3 raised to 1 upon x. Again, I have omitted one step. Basically, limit of log is log of limit. And what is a upon b raised to m? A raised to m upon b raised to m. Now we have solved, I think, 2 sums of this type. Something is added to 1. Same thing tends to 0. Index must be reciprocal of this and so on. Right done. Okay. See. Limit of quotient, limit of numerator upon limit of denominator. See, I expect you to again solve this after the lecture because these sums are important. Something is added to 1, same thing tends to 0. Required index is minus 3 by x, but original index is 1 by x. To get that back, raised to minus 1 upon 3. You can check this. A raised to m raised to n is a raised to mn. Yes, we have written the same. In the denominator also, a raised to m raised to n is a raised to mn. Now, I can say this is standard limit. Its value is e. So e raised to minus 1 upon 3 upon e raised to 1 upon 3. Use laws of indices. So this is log of e raised to minus 2 upon 3. What is log of m raised to n? In log m. So minus 2 upon 3 log e. So minus 2 upon 3 into 1, that is minus 2 upon 3. So this is the final answer. Of course, you have to mention standard result as x tends to 0 plus minus x upon 3 tends to 10 to 0. Limit y tends to 0, 1 plus y raised to 1 upon y is nothing but e. Better. Third one, first part, limit x tends to 0, a raised to x minus b raised to x upon sine 4x minus sine 2x. What is sine a minus sine b? In fact, there is no need to do that, but if you do so, then also you will get the same answer. But here they have just divided numerator and denominator by x. Okay, so in the numerator, subtract 1, add 1, right? So a raised to x minus 1 minus b raised to x minus 1. Divide numerator and denominator by x. So a raised to x minus 1 upon x minus b raised to x minus 1 upon x. Actually, sine 4x requires not x but 4x in the denominator. No problem. Multiply denominator by 4 and therefore numerator by 4. Here we need 2x. So we multiply numerator by 2. So we have written the same function in required standard form. Okay. Now use the standard result. So limit x tends to 0, a raised to x minus 1 upon x minus limit x tends to 0, b raised to x minus 1 upon x upon 4 into this. So log a minus log b upon 4 into 1 minus 2 into 1. Okay. So this is the reason for that. Now log a minus log b is log of a upon b. 4 minus 2 is 2. So half log of a upon b. You have to mention the reason. Second, let L be the limit x tends to 0, 2 raised to x minus 1 cube upon 3 raised to x minus 1 into sin x into log of 1 plus x. You have to divide numerator and denominator by x cube. Why? Because it is cube of 2 raised to x minus 1. If you take care of numerator, denominator will take your care. See, in the denominator also there are 3 terms. So we give x to each of these 3. 3 raised to x minus 1 upon x sin x upon x. Now, instead of writing log of 1 plus x upon x, I have written 1 upon x log of 1 plus x. Why? Because I have to write n log m as log of m raised to n. So, in the next step, I will write limit x tends to 0, 2 raised to x minus 1 upon x cube into limit x tends to 0, 3 raised to x minus 1 upon x into limit x tends to 0, sin x upon x into limit x tends to 0. What is n log m? Log of m raised to n. So log of 1 plus x raised to 1 upon x. Now in the numerator, what is limit of cube? Cube of limit. So this is limit x tends to 0, 2 raised to x minus 1 upon x cube divided by, actually we can write the value of this limit, 3 raised to x minus 1 upon x, but I will take all limits at the same time. Now what is limit of log? Log of limit, better I put this in bracket. Log of limit x tends to 0, 1 plus x raised to 1 upon x. See, basically this is limit of composite function. Limit of log, see, limit of logarithm of function is logarithm of limit of function. If you want, you can use bracket here. Okay. So this is log 2 cube upon log 3 into 1 into log e. What is log e? Log e is 1. So this is log 2 cube upon log 3. Why? Because log e is nothing but 1. This is the final answer. So we stop here.